All right. We might as well get started and see how this works. Okay, the recording has started. That's got to go down there. You are seeing a picture of the Namib Desert at the moment, so let's begin. I just clicked the button. Right. This is Marinus and Bernard gave this an enormously long title. Advanced AO Renovation Skills Transfer Workshop. Agenda. So I'm just going to go quickly through the agenda of what we're going to cover in the next. And honestly, I don't know how long it's going to be. It could be. I seem to have lost something. I seem to have lost this. It could be, I don't know, weeks, even to December. Let's see. It depends how well I go and how well you go. So what we will do is we'll start with looking at the agenda. The first item, review and understand the ILE programming model and its functionality. That, I believe, is something that is of interest and importance to you. And in my discussions, I have moved the stuff around in this course so that we can deal with them in what I think now is a better order. So that's the first one. We're going to look at the ILE programming model and what it is and how. We're going to then examine and understand the call stack and the procedures in the context of the ILE, because the call stack carries a lot of ILE information, and you need to understand that if you're going to work with ILE properly. Then we get to message percolation and the use of predefined messages. This is to pass messages backwards and forwards. Because remember, the purpose of this whole exercise is to actually reduce the modules of code and split up your large programs over time into small different modules, procedures, so that there will be a lot more pieces, but they will be much smaller and easier to manage. And in order to make this work, we have to have a way of communicating between these procedures. So this is where it happens, through the message percolation. Right, the next thing is we're going to look at the message handling APIs and the advantages of wrapping specific functions into a service program. So we're going to here talk about the message handling APIs that you have available and how you can put them together into a service program. So we're going to look for the first time at service programs as well. Then we're going to look at IO service, including their benefits, disadvantages, and their places in the data-centric architecture. This will also involve converting or building service programs with the IO servers as well. So you'll get another round of service program introduction. And then understanding the usage and limitations of before and after trigger programs. We're going to go with that in quite a lot of detail. How you use them and how you can manipulate messages through them. So that's why the message handling comes before the triggers and the IO servers, because you will see them come in there. Introduction to pointers and user spaces by special request of Bernard. What they are, how they work. And I have to admit, when I found these things, the user spaces and the pointer arithmetic that happens inside RPG, I decided they were the best things in sliced bread, and have never used a data area or a user index since then. Or what's that? What data area, or what's the other one? I don't know. Anyway, please, if you have any questions, please, I'm watching this thing, so please raise your hand and we can talk about whatever it is. It's important that you don't let me go too far without understanding what I've covered, because if you do, you're going to get lost. And that's not just, I'm not just saying that, it's happened before. The next thing is we're going to examine all the primary keys, unique constraints, check and referential constraints, including how we use them and what impact it has on your database. Then we're going to understand and create a JSON driver interface. This is for handling the communications coming in from the web browser. And AO does this, or in fact, the templates that we have been designed to do this. So we'll introduce you to them and talk about the protocols and how it all works. Then we will talk a bit more about some user spaces, because user spaces are very useful for all sorts of things. Only your imagination limits that one. And then when we get to this, I'm finished. You won't hear my voice again. And I will hand over to Marinus and Clifford, who will then take you through setup, configuration, and construction of the AO Open front end, which is your browser, and the communication in to the IBM I and into AO, or into the JSON drivers that we've discussed here. So that's basically going to be the agenda. I will and can deviate if you want me to. And definitely, if there are questions, I will answer them as we go along. I prefer doing that rather than leave them all to the end. At some stage, and I think Bernard has agreed with us, I will be asking you to do homework, you can call it, to actually build something. And I'd like you all to do it as a group, not as individuals. So as we go through, I'll be giving you things to put together. And I'd like you to do it all as a group, because I find that with this sort of thing, everybody understands something a little bit differently. So as a group, it works better. Okay. So while I'm getting my act together and trying to decide what's next, you can have a look at some elephants and other things. The first quiz is, how many different types of animals are there in that picture? Okay. This is just an introduction to me. I realized last month that in 1974, I joined a company that had a IBM System 3 Model 10 installed, and that was the first time I joined them as an RPG program, and that was the first time I was introduced to RPG. I have since then continually been involved with RPG, and of course 1974 August this year is my 50th anniversary, so I really was quite intrigued to notice that. And just to get this on the recording, I'm giving you all my contact details. You're more than welcome. If there's something you don't understand, or you want some help with something, or some code, or whatever it is, I'm more than happy that you just get hold of me, and I'll try and help you as much as possible. Or you can send me questions that I will then answer in the next session, if that's at all possible. So there are the contact details. Okay, let's begin. You're already comfortable sitting down. I can't even see the expression on your avatar's faces, so I don't know whether. What happens if you fall asleep? Does your avatar fall asleep too?
Good question. It's all new to us.
All right, integrated language environment. ILE. Now, it must be understood that the integrated language environment has absolutely nothing to do with RPG. Therefore, the statement ILE RPG or RPG ILE is not valid. It's not true. So let's have a look at the integrated language environment and see where RPG fits into this environment. It is a programming model which was introduced actually quite some time ago, as long ago as the AS400, which is a considerable time ago. But of course, not much used then, and it didn't have the type of functionality that it does today. And the whole purpose is to provide a flexible and efficient environment for developing and running applications. So let's have a look at some of the key features of our integrated language environment. The first one is it has what has been called a multi-language support. This means that you can use different programming languages, and here there's a list. RPG4 is a programming language. COBOL, C, C++, and CL. At the moment, there are 5 languages that can be used and mix and matched together to build an application, and using the best language for the purpose and for the skill set that you have. You can bind all of these different languages together to create an executable program. That's the first purpose of this ILE environment. But please note, RPG4 is a language that supports the ILE environment. So the correct term for RPG4 is RPG4 for ILE. Make that distinction, even though IBM doesn't really like it. They talk about RPGLE and all sorts of things. Right. Next key feature, modularity. It's designed to promote modular programming. Get rid of these huge monolithic 25,000 line or 50,000 line programs and start to reduce the whole thing to a very modular method or construct, very much like Lego, where you can plug blocks together to make things that you want. And the most important thing, that it's based on procedures. Using modules containing procedures, and a bit later the service programs as well, are also procedure-based. Makes it easier to develop, test, and maintain large applications by chopping them up into manageable components. Because if you have a huge program, I don't know whether any of you know what the biggest program you've got is and how many lines of code there is in it. But if you have a program like this and you make a 1-line code change, you've got to test the whole program. You've got, I can see people nodding in agreement, so your avatars cannot do. Hey, that's wonderful. You have, if you have it all broken down into tiny little procedures, then of course you don't have to. If you change 1 line of code in 1 procedure, you only have to test that procedure. You don't have to test it all. So that's what this is all about. The modularity that you can build in ILE is the most powerful thing about ILE. And I'm just going to do this to make sure that you get the message. ILE is procedure-based. It works on procedures at a procedure level. Programs are there really as a box for the procedures and the modules. Programs, modules in the box, and procedures in the module boxes. So you can break it up into very, very small pieces. Right, binding. ILE introduces the concept of binding, where modules are bound together to create programs. And you've got 2 compilers that you can use that for that. The Create Bound RPG, which I'm pretty certain you guys are using. Am I right?
Yes.
Yeah, okay. And of course, you can use a create program command to also create ILE programs. I'll show you a bit about how that works a bit later. And definitely service programs are bound together using the create service program command. Have you used any service programs, Bernard?
I don't think so.
Okay, you're going to have fun. Typically, programs have a single entry point. PEP, we call it a PEP. The old days, it used to be called program entry point. Nowadays, it's more procedure entry point because we are ILE environment and we are procedure based. I'm going to keep repeating that until you're sick of it. Activation groups. That was another question about what I needed to cover, was what are activation groups and how do they work? Well, they're an ILE concept that uses activation groups to manage the life cycle of the program and their resources. In an activation group, programs are activated and deactivated together. It manages resources and usage much more efficiently and gives you better control over your resources. And one of the things you don't have to do is to remember to clean up after you. If you use activation groups properly, you don't need to close files, you don't need to reclaim resources, you don't need to do any of those things that you used to have to do to make your environment tidy, because it tidies up after itself. So we will go into that in quite a bit of detail. Exception handling. ILE provides robust exception handling mechanisms that allow developer to handle errors and exceptions in a consistent and controlled manner across the different languages. This is very important because if you're using different languages, you have to be able to communicate in a consistent way between COBOL and RPG or C++ and RPG. Fortunately, I don't have that problem because I don't write in anything but RPG. And as a result, I can communicate quite nicely. Thank you. But it has got a lot of different error handling mechanisms. It's designed to improve performance. This is one of the main factors for it. Memory management, optimized calling of procedures, and reduced overhead on program calls or procedure calls. And let's keep popping that back into mind. It's not program calls so much as procedure calls. So those are the 6 key features of the integrated language environment. So we keep those in mind when we get on to the next step, which is to look at how we build RPG4 for the ILE environment. Now, I'm going to ask you guys for some feedback here to make sure that I'm on the right track when I go through this. So let's have a look here first. Constructing an ILE program. Do you guys use ILE?
Yeah. Well, all of our objects are ILE.
Okay, let's see. How do you construct an ILE program? You agree with me? You have file specifications in your program, correct?
Yep.
You have data definitions in your program, correct?
Yes.
Okay.
Correct.
And you have a main line. Now, that little circly thing, I'll come back to that. And you also have subroutines. Are those, you agree with me?
Yes.
Those
Yes,
are
we
the
are.
main. Okay. Now, that little circly thing there is the RPG cycle. Here's a question, and I want you to answer carefully. Do you use it, or do you not use the RPG cycle?
Well,
You don't.
we
Mhm.
do, but less and less. Okay. But
Okay.
yeah, we still have programs using the cycle.
Okay.
Diane, am I
Yes,
right?
yes, mainly for reports.
Okay. Okay. And your programs that you think don't use the cycle, do you have statements like open files on the F-specs? Do you open the files explicitly, or do you let them open automatically? Because if your files open automatically, you're still using the cycle. If you use the INZSR subroutine, the star INZSR subroutine, you're still using the cycle. So this piece, yeah, sorry.
We're using more the cycle than we thought.
Okay, you're using more of it than you thought.
Yeah, yeah.
Okay. Then in this case, this particular next phase is if you take these components and you use the create RPG program, you will have created an original program model, OPM, and you can only call this through a program call, and it can only run in the default activation group. Very restricted and limited by today's standards. So what we need to do is we need to look, first of all, I am sure you don't use create RPG program. I'm sure you use create bound RPG. And immediately you have an ILE program model. It's automatic. And this can be called by either program call or bound program call, call B, call or call B. However, when you use this compiler, you are actually generating a couple of other things that you are unaware of. The first thing is this code that you have here is compiled as a module containing a procedure. So immediately you use this ILE compiler, you actually take your code and you make a procedure out of it. That procedure has the same name as your program. And the procedure is wrapped in a module that has the same name as your program. And then the program is given a program entry point, which has the same name as your program. Okay, so that happens. There's another thing that happens that you probably are not aware of, is that attached to this compiled program are two tables, an import symbol table and an export symbol table. The import symbol table is a list of symbols, which are either names of procedures, variables, or entry points that a module or program needs but does not define itself. I.e., it needs certain things, but they're not defined inside its own code. The export symbol table is a list of symbols, also procedures, variables, or entry points, that a module makes available for use by other programs or service programs. Now, I'm pretty certain that in this particular case, the tables will be there, but there will be nothing in them. Because if you have a typical heritage program, you won't have anything calling outside. You won't have anything that you are exporting. So these tables will be empty, but they are still there. And an ILE program, that whole picture is what an ILE program looks like, including these two tables. You will see later on how these two tables become very significant in the whole process. Okay, so that is what we have. Now, why didn't that do what it was supposed to do? Right. So there is your ILE program. And we need now to start making it ILE. Really ILE, because this is not an ILE program. I hate to say it. It will function in a limited environment in the default activation group, but it has certain serious limitations. It can't use procedures. It can't use some of the more recent current built-in functions, and it can't use any routines that require to be outside the default activation group. So it's limited. So we want to change this to a proper ILE program. Now, please understand me when I say this. You don't have to rush off and over the weekend go and change every single one of your programs, please. That's not the point. The point here is if you have to modify a program or maintain a program or enhance a program, look at changing it to a proper ILE program. Some of them you can do, some of them you can't. I don't know your code. You're going to have to, what's the word I want? You're going to have to just use your own opinion about this. Sorry. Okay, so what do we do first? We have the RPG cycle. Now, unfortunately, I asked the question and you gave me an answer. You do use the RPG cycle. You may not be able to get rid of it yet. But if you can, it would be ideal to try and get rid of it, because the RPG cycle contains approximately 25,000 lines of code. And if you're not using the RPG cycle, that are not used and they're an overhead on your program. They enlarge the program, they waste space, and they are an overhead, which is not being used. So it's a good idea to try and get rid of the cycle. How do we do that? In some of your programs, you can say, I want to get rid of the cycle. I can do it this way. I want to convert from a cycle main procedure. This is what this is called. This is a cycle mainline or cycle main procedure. And to get rid of it, you're converting it to a linear main procedure. The way to do that is actually very easy. In your control options, you put in a main keyword with a bracketed program name. The name of this program, you put that program name in there. And then there's one other thing you have to do to your mainline code to make it a linear main procedure. And that is you need to make it into a procedure. So you take your mainline code and you declare it as a procedure, giving it the program name, the same name as you've got on your control opt. And then at the end of that mainline, don't worry what's in between. At the end of that mainline, you end the procedure. Having done that, you have turned your mainline into a procedure. And you can then say that I now have got rid of my cycle main, and I have now got a linear main procedure. I would like to add that you don't have to do that to get rid of the cycle. If you want to keep the cycle until you eventually work it out of the system, you don't have to do this exercise. It's not going to make it impossible. You still need to change the main line to a procedure, but it can be a cycle main procedure, not a linear main procedure. So either of the two work. I prefer to work with a linear main procedure, getting rid of the overhead. I do my own file opens, I do my own initializers, and it's much easier and it works better with ILE. And you'll see why later on. I'm sorry I can't cover it all in one sentence, but it does come in order. Okay, let's see what the next step is in how to. We need to convert for the next step to make ILE programs. We need to convert our subroutines to sub-procedures. You do have subroutines in your programs, I'm very sure of it. So how do we do that? Well, the first thing we do is we change all EXSR name operations to name, open bracket, close bracket. So that's your XSR subroutine. This is a shorthand of call P in your freeform ILE. You know, in freeform ILE, there are certain opcodes you can leave out. This one, where you just use the name and brackets, indicates that you're calling a procedure. You could type call P name brackets, but you don't need to. Call P can be left out because the ILE compiler recognizes this as a call to a procedure. So having gone through your program and done that, you need to go to all your subroutines and you need to change them to procedures. And it's just as easy as your mainline. You find a subroutine, you declare it as a procedure. You declare it as a procedure, and then at the end of that subroutine, you end procedure, i.e. you replace your big SR with a declare proc and your end SR with an end proc. What's in between does not matter. It immediately converts that subroutine to a procedure. One of the big advantages of a procedure over a subroutine is you can pass it parameters and you can receive values back from it. So it is much more functionally rich than a subroutine, which is why I recommend this exercise. And you don't have to do all your subroutines in one program all at the same time. You can do one and see how it works. Make sure you're comfortable with the method and what it looks like and how it feels, and then you can do others. None of this needs to be done all at once. They can be done in small pieces over time. And that's the way you must look at this thing. It's not a monster, it's not a mountain. It can be done in very, very small bites. Okay. So what have we got with an ILE program? We have now got a slight change. The file specifications you had up the front and the data specifications you had up front have now become global file specs and global data definitions. These are available to all the procedures in this program. That's important. They are available to all the procedures. It actually is not a surprise because your subroutine had access to all of these things anyway. But I'm being very specific, and the way I'm saying this at the moment is because there is a difference, and you'll see it just now. These are global file specs and data definitions. Then we have a mainline procedure with a PEP, program entry point, or procedure entry point, which, depending on whether your mainline, your cycle is in or out, will either be a cycle mainline or a linear mainline. Then you will have, following that, you will have procedures, and you will have, I don't know how many whether you break up things into subroutines, you might have 20, 30, 40 procedures. It doesn't matter. Makes no difference. But one thing about procedures, which you've got to be aware of and which makes them doubly powerful. I said already, you can pass parameters from one procedure to another, and you can receive back from that procedure, you can receive a value. Just to be absolutely technically correct, if a procedure returns a value or a result, it is known as a function. A procedure that doesn't return a result is a procedure. One that does is called a function. But there are a couple of other things about procedures that are interesting. First of all, you can specify local file specifications. These are file specs that only belong to this procedure and are not available to any other procedures in the program. You can also specify local data definitions. These are data definitions that are only available from this procedure and not from any other procedure in the program. And then, of course, you can have the procedure code that can work with your local file specifications and your local data definitions, as well as your global file specs and your global data specs, data definitions. So this shows the increased power of the procedure. It receives parameters, it passes, it can return values, it has its own file specs, it has its own data definitions. It's, in fact, and I want you to start thinking about it as I continue talking, a procedure is in fact a mini program. It has all the functions of a mini program. It's a procedure. So if you start thinking about it that way, yes, now you've got an avatar. Francis, you want to question?
What is when I will decide to use a global files, local file specification, instead of the global file? In which case?
Well, it entirely depends on what you're planning to do. Very often in a normal program, you will find no need to do that. But in a service program, and remember, a service program is made up of procedures. Different procedures might access different files for different reasons. And in your after triggers, you might have a procedure in your after trigger which processes one file and another procedure that processes another file. In that case, you may not need to specify them globally, because remember, when you open a file, and of course, if you're working with linear main and particularly with local file specs in procedures, you have to open them and you have to close them. Every time you open a file, it occupies space in the memory in what we call our process access group, which is your job PAG object, where all the information about your job is kept. Open files occupy space to keep all the file details. And the more files you have open, the more space you need, the more memory you use, and so on and so forth. If you don't need those files, it's a good idea to open them, use them, and close them. So that's the possibility. You don't have to, but they're there in case you need them. To be honest with you, I have to be honest with you. I've never used one. I did once for an experiment, just to find out what it was like.
But it's always in a case that you need to open a specific file for a specific procedure, then you can define it in the local file, the specification.
Exactly.
Okay, I understand. Okay,
thank you. You can
open
it, use it, and then close it afterwards and get rid of it.
Okay, I understand.
Right. So how do we, what do we do next? What are I doing next? Oh, yes. So we have here, we're creating a bound program. Oh dear, I thought I'd corrected that typo. That's supposed to be RPG program. And we've got a control main program name, which means that our program entry point is there. And now we have to do one last thing in order to make this truly an ILE program. And we have to kick it out of the default activation group. The default activation group is set up by the system when you start a job. And to be able to use all the ILE functions properly, you have to kick it out of the default activation group and push it out into another activation group. And the way you do that is quite simple. In fact, it's ridiculously simple. Oh, sorry, I forgot the import symbol tables and the export symbol tables. Those are also part of this whole picture. So what do you have to do to kick it out of the default activation group and give it an activation group of its own? It's too simple. You just drop in to the control options. You drop in another keyword called default activation group *no. That will cause this program to execute in a new activation group. Now, what activation group that actually is, we will talk about just now. But it will kick it out of the default activation group, and you will then have this program having all the ILE functionality available to it that you wouldn't otherwise have had if you'd stayed in the default activation group. So that's it. Now, this is my usual point at which I do this, and I say, are there any questions?
Not for me at this time.
Okay.
But maybe Luvic or Joel may have question.
You make sure you're following me at this point, please. Where's my little picture? I must turn my face on. Please, if you have questions, make sure. And if I mention anything further down the line that suddenly makes something I've already said out not nonsensical, please call me up on it and put up a hand. By the way, I noticed that when you raise your hand, your avatar raises its hand too, which is quite cool.
Question, Tommy, regarding the procedure. Okay, within the program, actually, let's say we are converting subroutines into procedures, for example. Okay, and all of the code is inside the main program. Okay, the the procedure code is within the main program. But let's say we have subroutines, which is exactly the same that is repeated in most of our programs. So that means can we just use a procedure by itself, like kind of an external to the program, an external procedure to that program, and code it only once?
Bernard, I'm so glad you asked that question. What you do with that procedure is you pull it out of your programs, or pull it out of all of your programs, and you put it once into a thing we call a service program, which I will talk about in detail later. All the procedures that are used in multiple places must be pulled out and placed in service programs, because in that way you have only one instance of the code you have to maintain. So yes, the answer to your question is yes, most definitely you can, and you must. One of the most important things about modernizing or renovating your code is looking for exactly this sort of thing. I'm sure it's all over your programs. Validation routines, tax calculations, discount calculations, I don't know, temperature conversions, all of these things are routines that are all over everybody's systems. And you need to start pulling those out and putting them into little boxes on their own so you can be used anywhere. Because that's what I was talking about earlier. You then only have to test that if you change it. You don't have to test anything else.
You
Sorry,
know,
Franz.
Tommy,
Yeah.
Tommy, actually we are doing that using a call program. Then this program going to be a service program. Then this is the way that we are doing as using an external RPG program to do several options. And if I understand, this program is going to be a service program. Then in the way that we are using a procedure many times in many different programs, then this procedure is going to be a service program. This is what I understand. Yes. Okay, thank you.
At the moment, if you're doing it, you're putting it into an RPG program and you're calling that program. Now what you do is you take that procedure, you put it in with lots of other procedures. IBM recommends you don't put more than 70 procedures in a service program. I have service programs I'm running with 160 procedures in it. Remember, in a service program, every procedure is independently addressable. So you can call any one of 100 procedures that are in a service program anytime. There's a huge section on service programs we'll be coming to show you exactly how they're used, because they are, in my mind, next to pointers, they're one of the best things that ever happened to this platform. So let's take it. But yes, you're right. Take these out, put them in a service program, cuts down the overhead, makes them available to all sorts of programs in one place. Okay. Right, can I proceed, or are there any more? No? Okay.
Go ahead.
Let's look at another way of constructing ILE programs. Now, this is similar in a way to what Francis was saying. We can build modules. Remember, my idea is to take your huge monolithic programs and through a process, gradually smash them down into small pieces. So this is another way. Here we have a module which we have created, but instead of using your create bound RPG, we use create RPG mod. This creates a module. It's not executable, but in this case, you've got a main keyword. So you've got a program entry point, and you've kicked it out of the default activation group by using that keyword. Now, this module can contain some of the processes you want in your program. You can create another module that contains other processes that you want to use in your program. In this case, you use a different keyword here. In control opt, you say no main, which means there is no main line. Whoops, sorry, no main line, i.e. there's no program entry point. Now, in this case, we get some interesting things, and this is where the import and export symbol tables kick in. All code in the module has access to all other code in the module by definition. But if if the mainline procedure code here wants to access proc X, which is not in this module, while you're compiling this module, it will see that it's not available, so it will put that into the import symbol table, saying, in order to complete this exercise, I need proc X. What we would have to do here on this module is to add an export keyword to each one of the procedures here, and they would be put into the export symbol table with their location. So here we have, when you run the create program, it runs in two stages. It first compiles them, goes through this module, compiles this, looks through the symbol tables, etc., and then does a binding step to bind these procedures together, so that when this call occurs, the import symbol table has a location to the export symbol table, which has a location which goes to that procedure. So you can execute this procedure from inside that module. It means you can break your programs up into some logical groupings. It also, and I'm very sure that possibly Francis and one or two of you others have already seen, that you could put in this second module, you could put common code, and you could bind it into different main modules, i.e. you would get this code bound into different programs. It is a possibility, not one I recommend, because in fact, when you bind this code in a create program command, it puts both pieces of code together. So when you are actually storing this program, and you do that 3 or 4 times, you are storing this module many times. And if you make a change to the second module, you have to compile all the programs that use it again. So it's possible, but not recommended. I use this technique to break up very large programs into smaller and smaller and smaller pieces, so that they are easy to manage, to maintain, and to keep tabs on. Because if I want, I can change one procedure in one module, and I have to then recompile the program, granted, but I don't have to test anything except the procedure that I changed. So that is ILE from modules. And that's where the create program command comes in. Okay. Yes. Ludwig.
Could you use the export keyword on proc A from a main program?
You
or
could.
It's only 2 no mains?
Yes, you could. And what's
Okay.
more, you could access proc A from proc Y. You can access Boeing both ways. So,
Okay.
yes, you can. Be careful, though. Be very careful. This can, if you just go a little bit crazy, this can get very complicated. And sometimes it could get totally out of hand. So, but what we've looked at here, these are ILE programs. I do this occasionally. I make up a program of 3 or 4 different modules, and I will bind them together depending on the size of the program, the requirements of the program, and the logic behind the code. It doesn't say you have to, doesn't say you mustn't. It entirely depends on the circumstances. And this you must remember, because otherwise you can get yourself into awful trouble if you try and, oh, we all know the saying, banging a square peg into a round hole. We all know what happens. Hey? All right. Any questions at this point? We've had one. Any more? Good. We will continue. And here comes the the main topic of today's course or today's exercise, activation groups. Now, we've talked about the key elements of the activation groups. Now let's look and see how you can use them and what they do for you, because this is vitally important. You've got to understand activation groups, otherwise you cannot make them work. First of all, it manages, this is just a recap, it manages the life cycle of programs and their resources. Step 1 is a collection of programs and service programs that are activated and deactivated together. So they're like in a basket. It helps in managing memory and resource usage more effectively. Those are the 3 main reasons why we use activation groups, but we are going to talk about a dozen others when we get there. Let's have a look at them. When you start a job on the IBM, and that is when you log on, or when you submit a job to a job queue and that job executes from the job queue. Those are the only 2 instances where a new job is created on the IBM I. Okay, I think this is probably a good point in which to put in my disclaimer. I don't teach, and often I'm not even aware of the underlying technicalities that go on and how this thing works. All of this I've done, and it works, and I explain it in the simplest possible terms. If I go into too much technicality, which I don't, some of it I don't even understand myself, it gets too much of a complication. So I'm not always technically accurate, but you can believe it works. Right, so we have the 2 types of jobs. It's a batch job and a interactive job. There are others, but we won't go into those. They're rare. You can't terminate an activation group except by ending the job. And the default activation group is where all original program model and OS functions run. All operating system functions run in the default activation group. So here, you can still have your ILE programs or your RPG4 programs compiled like you do them in Create Bound RPG. They can run in the default activation group, but they are limited in function, as they can't use any procedures, they don't call any procedures, and they use no contemporary built-in functions, as well as any features that require procedures not supported by the default activation group. So you can run your programs in the default activation group, but only the way you're doing it at the moment, with subroutines. You can't use procedures. You can't call procedures. You can't use some of the built-in functions, which are more the later, fancier ones you can't use. So there are limitations. So let's have a look at what is an activation group, or how do I manage? First of all, how do I get an activation group? Now, there's the program that we're used to seeing, and there we have default activation group no. i.e., when this program executes, it's going to kick itself out of the default activation group. But where does it go to? Where does it actually run once it's out of the default activation group? Well, it basically creates an activation group of its own. And you can control which activation group it actually creates. And there's benefits to all of them. You need a new keyword up here called activation group. Now you're saying, I don't want the default activation group. I want to use an activation group, and it's either that, which stands, by the way, for storage model, new, caller, or activation group name. You can give your own name to the activation group. Now, each one of these things has a different effect. If you use storage model, now, technically, I don't know. I know there are two storage models in this system. One is the single level storage, and the other one is the TerraSpace storage model. I've never read up. I don't understand what TerraSpace is, but I think it means that you can use a lot more and have much bigger programs and data files and all that sort of thing. I don't know anything about it, and I don't want to. If you use storage model, which is, by the way, the default, if you don't specify this keyword, storage model is the default. It will give you, if you are on a single level storage model, it will give you a named activation group called QILE. So it will name an activation group for you called QILE. If it's a TerraSpace model that you're running in, it will be QILE-TS. TS, I'm assuming, is for TerraSpace. And it will then open an activation group with that name. And then this program will be activated inside that activation group. I'll draw pictures for you just now. New activation group, new activation group says, I want a new activation group. I don't want to give it a name. Mr. Operating System, I want you to create a new activation group for me. And I want you to give it a number, and I want you to manage it. So a new activation group is a system managed activation group. And that has some very significant differences to named activation groups. Star Caller says this program must run in the same activation group as the one that called me. I don't want to start a new activation group. I want to continue running in the preceding activation group, the activation group from which this call came. That is very common and is mandatory for all service programs. But we'll worry about that a bit later. Then you have this activation group, which you give your own name to. Now, I've found this very useful when I'm processing transaction tables, transaction files that contain many different transaction types, which are being processed differently. What I do is I identify a transaction type and I pass it to a program that uses an activation group designed specifically and only for that transaction type. So I might have 6 named activation groups for 6 different transaction types. And you'll see why when I show you what happens. There's a distinct difference in behavior between a new activation group and a named activation group. And we will talk about that now. Everybody comfortable so far? Okay. Here we are. This is in picture form, comics. When you open a default activation group, or when you open a job, you get a default activation group. The first program that runs every time you start a job is Q command. It's at the top of every call stack. It is the first program to run. And that is the program that actually starts up this activation group, which is a nice big blue one, plenty of space to hold everything else. Let's see what happens next. The Q command could be showing a command line. It could be showing a menu. It could be showing all sorts of things. And obviously, from the command line or from the menu, you will execute another program. I'm sure you understand the concept. If you don't, ring a bell, otherwise I'm going to continue. So we would call a program. And this program, if it's compiled with activation group star caller, it will also run in the default activation group. So it'll open a file. The file is opened in the default activation group. And the default activation group only closes when you end the job. Right, let's look at what happens if this program calls another program, but this one says, I want a new activation group. This program will activate a new activation group and will begin executing. Now, this is a system managed activation group. It will call another program, which will open a file and do something. Because this is activation group star caller, it stays within this activation group. This file is opened either implicitly or explicitly. You don't have to close it. I'll show you why. If the call goes back to there, notice that this program does not end. It stays active. The file stays open. The program stays active. The file pointer points at the last record it accessed. Yes, Francis. Francis,
just a small question.
Yeah.
By default, if we don't specify activation group color, is it the default value? Is it stay on the same,
no.
You know,
Your
is it stay on the same activation group?
No, it's not. Because your default is, if we go back here, sorry, let me go back. Your default, if you don't specify activation group, your default will be storage model. And storage model is QILE. Now, if you are here, okay, and you don't specify activation group, it will open a new activation group called QILE.
Okay, QILE is the default. Okay.
So this, I have control ops on the beginning of every single one of my programs, and I make sure that they are properly, particularly the activation groups are properly defined. Otherwise, it can get a little messy if you're not careful. So what happens here is we exit that program. It stays open. This is part of the activation group management. It stays open. If I call it again, it's all there. I just go straight back to where that program was. Call it from the beginning, the files are still open, everything is there, no overhead. But if I call another program, this one's also star caller, it also opens in this activation group because it's star caller. If I return to that program, that stays open. I'm in this one activation group. Now, before I move on, let me explain. You've heard about commitment control. Yes?
Yes.
Commitment control allows you to make changes to the database and then either commit them or roll back, depending on if you get an error and you want to roll it back. You might make 6 different updates to the database and you want to roll them all back because they were not right, or you want to commit them all. Okay, now commitment control boundaries are activation group. Let me explain. If this program here made a change to that file, and this program here made a change to that file under commitment control, and by the way, everything should be changed to commitment control. But there was a change there, and there was a change there. If this program issues the commit, only this change here. Damn this thing, I want to get my pointer. Only this change here will be committed. This change, which is in a different activation group, will not be committed. Okay. So commitment control only is limited by the activation group boundaries. Okay. So here's what happens. This is a new activation group. This is a system controlled activation group. It's a system managed activation group. So when I return from this program to that program, the system reclaims all the resources from that activation group. Now, part of the reclamation is, first, commit all uncommitted changes. Secondly, close all open files, terminate all programs, and return control to the calling program, i.e. recover that activation group in its completeness. If I return from this program to that program with an error, very important, something different happens. If I return that way with an error, the system will recover everything, but instead of doing a commit, it will automatically do a rollback. So if you've made changes in that activation group and you leave the activation group with an error, all your changes will automatically be rolled back. Am I making sense? Are you understanding what I'm saying? It's important. Do you use commitment control at all? Or not?
Not much, no, not yet.
But you are aware of what it is.
Yes, we
Yes,
are.
okay.
It's just that, okay, depending on the error, if let's say the error is shutting down the program,
Right.
I agree that this should be rolled back. I agree.
Okay.
It's okay.
No, okay. If you have already committed it, of course, it doesn't roll back stuff you've already committed. So if this program here does a commit and then sends an error message back, those commits are not going to be undone. The commit here will be committed on these files here and there before rolling back. So the boundary of commitment control is an activation group, which is quite interesting actually, because if this program gets called, if you want to use commitment control, this program needs to start the commitment control. You know the command start commitment control? It needs to be done in this program to start the commit cycle for this activation group. You must start the commit process for every activation group you open. I hope you are with me. I'm not confusing you too much. Right, let's have a look.
It's
Yeah.
just, it's new.
Yeah,
You
I
know,
know it's
we
new.
we know commitment
Okay.
control. We know that. It's just that we are not using it on a daily basis. Let's see. Let's put it that way.
Okay. It eventually, as you move forward, hopefully it will become sort of the normal part of development, because that's the way I do it. I have commitment control on everything all the time, which means I don't have to worry about half completed transactions ever. I design commitment control so that if I'm updating a dozen files by one transaction, I will wait until that transaction is complete before doing the commit. If any one of those parts of the update fail, then I will simply roll back. And that means all of that comes out and I don't have an incomplete transaction. That's the purpose behind commitment control. Right, let's have another look at the next thing. We call a program, but this time it's got a named activation group. What is different? We call this program, it's got a star caller. We go back, we call from there to there, it's got a star caller. We go back and we call that program. It activates that program. We call that, oh, look at that. This program at the bottom here wants to call that program. That program has already been called, so all its resources are open. There is absolutely no overhead on that call because the activation group has everything open and is holding all the resources. As a result, there's no overhead on the open or the call, and that's where the process of speeding up these calls takes place. That's where named activation groups are very powerful. Oh, we call from there to another program which has a new activation group, so that opens a new activation group inside this named activation group. And I haven't been able to find any statement by IBM anywhere that tells me how deep I can nest activation groups. I would just use caution about how deep you do, because it could be a pretty hairy business. If that program ends, of course, it will recover that activation group because that was a star new, which means it was a system activation group. Okay. Let's go back. That goes back. That goes back to there. Now, that goes back to there. Now, here's the difference between the system activation group, the system controlled activation group, and the named activation group. If I return to the calling program, this activation group stays open. Doesn't shut down any of the resources. It keeps all the resources open and all the programs are active. So if you call that again, everything is there. Now, remember what I said earlier, I use it for transaction processing, where I have a different named activation group for each transaction, and they all stay open. So only the first call to that transaction processing opens the activation group. After that, it's always there. It makes the whole process, and it's actually surprising. I don't know if you process transaction files of 1 million records or upwards, but it can make a significant difference to that type of processing by using activation groups. Right, so let's continue. Let's assume I call that program again, and that program calls this program again. So now we've got a new activation group, which is this green one, which is called this and activated this program. Now, I want you to think carefully about this, and I need an answer from you. If this program here calls that program there, what happens? Anybody?
There's the new one at the right should be at the same activation group as the left.
Good.
I mean, it could be twice in
Yes.
the orange one and the green one.
You are absolutely correct, Francis. Thank you very much. Nobody else was going to hazard a guess. This program will in fact be opened again in this green activation group. So this program will be opened twice. And this file will be open twice. It will be open with two open data paths, one from one program, one from the other program. And it can get pretty complicated when you start thinking about commitment control. Because if I exit sorry, I missed it. If I exit from this green activation group, I'm going to commit all the changes. So this file will have changes which were made by this program in here. This program in here will be committed, whereas the changes made by this program in here won't be committed. Am I making sense? Please tell me
Yes.
I am.
Should we call twice a program with, the first one activation group with a name? This program could be called more than one time?
Yes.
Twice?
It can. It's possible. And if they're in different activation groups, if you've got one in a named activation group and one in a system activation, or even if you have the same call in another named activation group, it will appear twice. Remember, an activation group is an environment where those programs are isolated from all the others. There's a commitment control cycle around each activation group box, and they are all protected from each other. So it can get very complicated. And this is why I'm always saying activation groups are a very, very powerful tool. But if you don't understand them, they can turn around and bite you. Who knows Spider-Man's uncle's greatest saying?
No.
With great power. Yeah. Activation groups are very powerful, but with great power comes great responsibility. You've got to watch out where you go with this thing. Otherwise it can. And the problem really is if you're splitting these programs up, making them smaller, turning them into procedures and all that sort of thing, it can sometimes be very difficult to track down where the problem is actually coming from. So don't just go ahead and randomly create activation groups. If you wish to get your programs to use an activation group without all the complication of multiple activation groups, leave out the keyword. Leave out this keyword here. That means default activation group says no. And that means that the activation group that will be created is called QILE. And everything will run in QILE as a separate activation group. You will then need to take all the responsibility for recovering reclaiming it, because remember, a named activation group doesn't automatically recover its resources. So you will be perfectly okay. You will be out of the default activation group. You will be able to start commitment control. Your commitment control will be completely job wide, exactly as it is at the moment. But you will have to close that activation group. And that is what happens when you return. When you return from this activation group back to that one, this activation group remains open. All the resources are there and everything is still active. If you wish to manually close down that activation group, there's a command called reclaim RCL-ACT-GRP, reclaim activation group. And you can reclaim the activation group, but you can't reclaim the you can't issue that command from inside any program that is actually in that activation group. So this activation group is called name. The only program in this scenario that can reclaim that activation group is this one here. This program would then say reclaim activation group star eligible, i.e. reclaim all eligible activation groups, i.e. ones that are not actually active. And it will close down and reclaim all the resources that were open, which is why I drew this diagram the way it is. This one is actually in the default activation group and it's controlling this. The only other way to reclaim all those named activation groups is to end the job. Then you will be reclaiming everything. It will reclaim everything back in a controlled manner. It will close all files. It will commit all changes, etc., etc., etc.
Where do you put your start commitment in this case? At the first one, the other one?
In this case, it would be in this program here.
Mm-hmm.
Start commitment control would be in that program there.
Okay.
In this case, it would be in that program there.
Okay.
That's how you would start your commitment control. Because if you don't, then a program that tries to do a update with a commit on it is going to fail. It's going to give you an error message.
Mm-hmm.
It says, I can't because there's no commitment control started. I'm sure you've seen that message before.
Yeah.
Okay. Francis, how many years of experience have you had in this RPG?
Who?
You, Francis.
30 years, maybe?
Okay.
Over 30 years, yeah.
Good. You've been around the block. Okay. That, I think, is, yeah. Any questions? Any other questions? Now, I know this is probably not sitting comfortably with you at the moment.
Another question. I just want to be sure that within a program is failed, then if we start a commitment control and within the same activation group, the program is failed.
Yes.
Maybe I don't understand. There is an automatic rollback?
Only if you exit that activation group. So let me get back here.
I am on the same activation group. Then for a reason, in the green one, the program is failed,
Okay.
and I'd like to know if the rollback will be done automatically.
If a program like this fails,
mm-hmm.
It will send a message back here, or it must. This is one of the things we're going to talk about is error handling, because
Okay.
to use activation groups properly, you need to make sure you handle the errors. If the error occurs here, this program must be notified of the error. And then this program must notify that program of the error. And that's done using an escape message. Now, the minute an escape message goes from there to there, a rollback will occur.
Okay.
So
but the robot will be done only if we've got the escape message.
It'll be done on
you
these
know,
two.
if yeah, okay.
Oh, does that make
but
sense?
any rollback will be done automatically.
If
we need to manage the error message to do a rollback within the program.
That's correct. An error message has to go from there to there.
Mm-hmm.
And that says, oh, you want to close down this activation group with an error message. I will then roll back and then reclaim all resources. If you go back there without sending an escape message, then I will commit and reclaim resources. So even if an error goes from there to there, if it doesn't go from there to there, you're going to get a commit. Does that make sense?
Yeah. Okay. I'd like to prefer to have a rollback instead of commit, but you know, in the way that we have a program failed. Yeah.
Yeah. If it'll roll back if the activation group ends with an error message, an escape message.
Okay.
And this is the only program that can end the activation group. You always have to go out through the program you came into.
Okay.
It's often a good idea in the beginning when you're starting to use activation groups to draw little diagrams like this to see where you are. Okay. Just something to think about. I'm sure you've all been there. Right. All stacks.
For me, Diane has a question.
Sorry, I've lost. Where's my... Oh, Diane and Ludwig. Okay, Diane, go ahead.
Yeah. Suppose that instead of having a name default name activation group and neither new. You said earlier that if we don't by default it will, if we have a default activation group no, it will be in QILE something.
Yes, it'll be in QILE. It will create an activation group and it will name it QILE.
When the program that opens the activation group QILE ends, will it close the this activation group?
No, because it's a named activation group. It's a default name, but it's still a named activation group. So you will have to either end the job or a program outside that activation group will have to reclaim the activation group. That's why I don't recommend it, because it's better that you know what you're dealing with. But it is by default, it's a named activation group. It's the quick and easy way to get out of the default activation group. But it means you're working with a named activation group. So all the rules of the old way of doing things still apply. You still have to close files, you still have to tidy up, you still have to commit, you still have to roll back, you still have to do all of that sort of thing because it's a named activation group.
Okay.
Ludwig?
If we don't want to make too much changes, could we just create like a one name activation group and all our program will run this in this activation group?
Yes. That's the easy way to start. That is the easy way to start. You can then, in answer to this question, I've just had another thought. and I need to come back to here for a moment. I explained to Francis earlier that you have to send an escape message back in order to get a rollback. The same applies to a named activation group. If I exit this named activation group normally, it goes back without any problem. Oh dear, where am I? Sorry. I've got so many buttons looking at me here and I don't know where I am. Right. Oh dear. Okay, when I go back like that, if this program exited by sending an escape message to that program, then even though this is a named activation group, it will be rolled back and all resources will be covered automatically if that message goes back there as an escape message. Okay, does that answer the question? So you could create one activation group and run everything for the job in one activation group. Yes, not a problem. And a lot of people start that way. But you still take responsibility for commitment control, for rollbacks, etc., etc. Unless you send a message back there to say, escape, abandon this activation group, and then it will close it all down for you. All right. Ludwig, have you got a question still?
Yes. For a test environment, could you create a different activation group, then force rollback at the end to only test the changes, then rollback?
You see, the thing is, creating an activation group is done when you call a program. So you call a program for a test purposes, you're creating a named activation group. If you want to roll it back, you have to have this program either issue a rollback. That program could issue a rollback, in which case all the commits in that activation group will be rolled back. So as a test, you could say, is this a test? Yes, rollback. No, commit. So you could do that in that program.
And it would revert all the changes made to the tables and
in a test environment, all of them. Because remember, a single commit commits all changes in the activation group that have been made to that point, and a rollback rolls back all changes to the activation group that have been made into up to that point. Does that make sense? So
yes.
even if this program makes changes here and this program issues a commit, those changes will be committed because it's in the same activation group.
Okay, thank you.
I know some people use conditional control option parameters. I don't. Do you ever use any of those, Bernard, in your programs? Qualified control ops.
Maybe Diane can answer, but I can't.
I don't like them. People use them. They say, if it's this sort of compile, then do it this way. And if it's that sort of compile, these are valid. It gives me the creeps. So I don't use that. All right. Oh, we were there. Yeah. Okay. Right. Now, what is the time anyway? Oh, we've got a little while because I have got some homework I need to get you to do for me. Call stacks. We'll get as far as dealing with these call stacks. Are you all familiar with what a call stack is?
Well, a call
Not too much.
stack is, let's say we log into a session on the IBM.
Yeah.
So we're up to the menu,
Right.
and then we call it. We select an option within the menu. So then we have a few steps already made. You know,
Yes.
so few programs are already into memory for me for my session.
Right.
And this is the call stack of everything that I did so far and everything that is running into memory so far.
Yeah, you're absolutely correct. It's a stack of calls.
Yeah.
Actually, here's an example. I took this out and I colored it so that we could have a look. This is part of a call stack. It's not the top of a call stack. I will go into a bit more detail on the green screen. But a call stack, every time you issue a call, right, it adds a new level on the bottom of the stack, i.e. if program A, this program here, this one here, is actually a procedure, calls that calls that calls that calls that, and so on and so on. Each call that is issued adds to the bottom of the call stack. So the latest program will always be, they're actually currently executing procedure will be at the bottom of the call stack. Does that make sense? Please, it's important to follow me here because otherwise I'm going to lose you very easily. If a program pass is finished and passes and ends normally and passes control to its caller, you move up one in the call stack. Okay? And it apparently appears that the call stack, the entry at the bottom, disappears as you move up the call stack. You go back and you go back and you go back, and they seem to disappear, but they don't. Call stack entries are not removed. They become inactive. They're known as inactive call stack entries, and you can't see them, but they're there. In case you call that program again, it will simply call it into the call stack. It brings it into the call stack. So all the ones above the currently executing program are active. All the ones below are inactive. And the ones inactive you can't see and you can't do anything with them. Let's have a look at what's here. There's a program name. Actually, let me go back. This one's better. There's a program name and library. Yeah, program name and library. The statement on which that program was when it called out. This is the procedure that was called. And what's important to understand here is if you look at this program here, AOF M000G, it's got a PEP. There's a PEP sitting there in the call stack. The PEP has its own call stack entry. The program entry point has its own call stack entry. It calls a procedure. That's a procedure. It's black. It's a procedure name, which actually is the same name as the program. Because when you create a bound RPG program, it creates a module which has a procedure which is the same name as the program. So the program and the procedure are all the same. So the PEP is the program, this is the procedure. So you call here, you end up there. This one got to line statement 87 before it called out to another program, which was another program PEP with another procedure. And so we go down the call stack. So the call stack is a matter of calling down as you call from one procedure to the other. It's a procedure. I'm going to repeat it. It's a procedure. It's not a program. In the original program model, the call stack is made up of programs. In the ILE program model, the call stack is made up of procedures. All of it is procedures. Very important. And one of the things one must understand about the call stack, which is most important, is that every single entry in the call stack has its own message queue. You know, like your user message queue? Every single program and procedure in this call stack, every procedure in this call stack has a message queue. It's the procedure message queue. And every single one has a message queue of its own. So now I've got to push a few buttons. Just bear with me for a second while I find out where I am. Right. This is, I don't know how familiar I know Bernard's familiar with this menu. I don't know whether anybody else is. This menu is displayed by the AO driver. And I can see the call stack by, I'm going to put this one up here. And I'm going to work active jobs. And I'm going to do a 23, is it? A 10 to display the call stack for this job. Now, this is a real call stack. Can you all see this screen? Is it all right size-wise? It's not too small?
It's okay.
Okay. Any call stack will always have Q command at the top. That's guaranteed. QIC menu driver, Q command. There is your command processor, which is the first thing that happens whenever you sign on to a job. And now a logon, if you type the AO command, you will get this program, which has a procedure. So you can see there's the PEP for the AOF under bar D. That's the driver here, is the menu driver that's driving that. It also calls a service program, which is a procedure to display a panel, which is the panel you are seeing there on the screen, is that procedure there. And in order to display this panel, it uses a product called UIM, and those 4 calls are all to do QUI is the UIM processes that are called from there to display this panel. You will notice something extremely interesting. These are queues, and I'm going to open another window here. I'm going to work active. I'm going to change, there's the same call stack, but I'm going to press F11, and we will see the second panel, which is the activation groups. And you will notice here, this one here says default activation group right up to there. And then as soon as I call AOFD, I get star new activation group, number 14. Actually, this is a hex number, it's 14. You will notice that these system called things are running in the default activation group. And that there is what is actually displaying the call stack. Does that make sense? So I'm going to open the fourth window here and do the same thing. This is where we'll, I think, come back to this next session. I'll press F11 twice here because those are the three windows that you see when you're looking at the call stack. And the only AO function is there. It uses a service program to display the panel. Now I'm going to pick up work with dictionaries. It opens another panel. Refresh this. You'll notice that here we've got another call to another program. Here, you will notice it's the same activation group, even though it is interrupted by some default activation groups, but these are system programs. So this is a new activation group, and this is the module. Notice the module is actually in QTemp library, which is quite extraordinary because a module is temporarily kept there while it's in processing. Okay, you'll also see there's 300D, which is another call down the call stack. It's another program. There's a PEP, a procedure, and a procedure. And again, another display panel, which is the one you're seeing there. So this call stack tells you very clearly which activation groups are active. Now, if you look here, this AOFG has an activation group of 14, which is the same as that one, which means that this has a caller of an activation group star caller, because it's the same activation group. However, this one has 17. It must have a star new activation group because it's a different activation group. What else can we get from the call stack? Okay, I want to finish off. We've only got a few minutes left. What I would like you to do is, Bernard, have everybody got access to AO?
Yes, do
Okay.
Yes, we have.
So you could do exactly what I did here and go onto the menu and pick one of these and then have a look at the call stack and see how it changes. You'll notice various things, like here at Q command, which is the top of the call stack, is a control boundary. That is significant. A new activation group, you start with a new control boundary. You go out of an activation group, you come back into the same activation group, you have a control boundary. Now you can look at this control boundary and you can see it doesn't actually help you an awful lot. It says whether there's a control boundary is active for a particular program or procedure. Obviously, it is, because it says yes. But the interesting part about it is if you want to send a message, you can send a message to the control boundary. You don't need to know what the program is. You don't need to know anything about the names. You can send a message to the preceding control boundary. And that means you would skip over a whole lot of these procedures and programs that are between the control boundary and where you are. So you must see this call stack as just a heap of programs. You're at the bottom is the active one. And then it's how you got there is what is above you. If you can use AO or even your own menus as well, and I would ask you to do both, to look at the call stacks on and see if you can understand what the environments are. You will see in your own, if you're not using activation groups, everything will be default activation group. They'll all be default activation groups. Whereas AO, I use numerous activation groups for different reasons. So you will see there are changes as we go down. So if you can do that for me as an exercise before next week, I would very much appreciate it. Just to familiarize yourself with what I've thrown at you now. I know it's much easier to do it in your own time than it is to do it while I'm busy talking. So if you can do that. The other thing I would also like you to do is, Bernard gave me 2 files, or Bernard, you gave me a whole library of which we are going to use 2 files. Sorry, work, PDM. I created a schema called ABC, which of course is American Built Right Canada, train. And we loaded the entire environment that you gave me into that library. But it was a lot of files, and we want to work with only 2 of them. So what I did, I've just got to check this now. Yeah, that's right. What I did was I actually would like you to do the same as I did. And that is I created a database environment called system name. Of course, your system would be a different name to this one. I created a database environment called ABC train. And I said, transfer, normal environment. So I created that. And then what I did was I created a library, which was also A, B, C, because this was where I put your files that you sent us. So and I've got a dictionary. I don't know what dictionary you've got. I've got a dictionary called AB Canada. The rest are set as defaults, and I saved that. So I've created an environment. And then what I did is I used this. It has no files in it. So I used, I think it was the, oh, yeah. The trick here is if there's no files, if there are no files in your schema, you can't import anything. So what I did just to get it started was I created a file just like that. Just created any file, it doesn't matter. Then I can double click on that and I can do an import. What I then did was, what is it? PROD. Is it ORD, Bernard?
Yep.
PROD. Okay, so I imported that, which means I can now delete this because I just needed that to get to this menu. Then I need to import another one, which was PROMIP7, huh?
Yep.
MIP7, PROMIP7. PROMIP7. And so those are the two files that we're going to use throughout this course as we build triggers, IO servers, constraints, and everything else. We're going to build them onto these two. Now, if you could just get one environment, I don't want you each to have your own environment. I just need one environment where you can all work together in it. Is that possible? I can't see that that's a problem, Bernard.
No, that's not a problem.
Okay.
I don't recall what was the D and B type. Is it normal?
The D and B type?
Database. Yeah, into the environment.
The environment. I've called the environment the same as the schema.
Yes, but the type is normal. It's not a master or a shadow.
No.
It's normal.
No, it's normal.
And the target system.
Don't worry about it because we're not going to be promoting this anyway, so you don't need the target.
All right. Okay.
You can just create it as a single level. If you look at it, you will see it appears here in my list. This is my test environment, so don't worry about the number of things. You see it's there. It just appears as a dev. Okay. Now, just as this is what do they call it when you find something in unknown? There's a thing here. In this blank space here, there's access to the new version of the workbench, which is still definitely work in progress. So it's hidden. But if you double click on that, you will see the same two files, but they don't look very different. This is the new version of the workbench, which you will have when I'm finished with it. But it's got Q here, so you can use the Q and you can actually see the contents of the files. It runs a query on the files. So we've got an awful lot of records there, which we're going to have to work our way through. I don't know. But that's you will find that, what is it they call it?
Undocumented feature.
No, it's got, these guys have got some particular word for these hidden nuggets that are around the place. Anyway, doesn't matter. So if you could set that up and then just spend a little time looking at this call stack. I think just to be more comfortable, we will review it. If you have any questions, if you could send them to me by email, you've got my email address. Just send them to me on the email, any questions that you might have. I can then prepare answers and come back with something sensible. Gives me time to think about it as well. So how's that sound, Bernard? All okay for you?
Well, yes, it's okay, but I'm at the stage of creating the environment into AO, and you were talking about ABC train, which is on your system, but it's not on ours. So I should create a library ABC train, isn't it?
That's it. Then you put the 2 files you sent us, you put in there.
Okay.
And then you just create an environment and a schema, and you put it into AO as a separate environment, completely separate from everything else.
Okay.
So we don't run over anything that you've already got in there when we do the various exercises. Okay.
Which is going to be test and so we're going to put those 2 files into this library, into AO as well, a definition and so forth.
Yes.
But this is only a small part. What else should we do?
No, and all I want you to do then is to have those 2 files there, because as we go forward, we'll be writing triggers for them. We'll be writing constraints and all that sort of thing for them. So just to get the environment set up so we can start defining the various components inside AO.
Okay.
For that environment, as well as using it together.
Okay.
And then if the other exercise would just be to try and get into this call stack and begin to look at it in a little bit more detail. Okay, and try and understand what all the bits and pieces are.
Okay.
You will notice mostly it's procedures. Yeah. Obviously, all the Q programs don't have procedures. They are enigmatic. They don't say much about themselves at all, except that they're in the default activation group, which is, of course, number 1. And they have no modules or a statement identifier. So really only the user created stuff is actually showing any detail whatsoever. Okay. Sound good?
Yes, sounds good. So are we gonna get the recording directly, or how is it gonna work?
Yes, Marinus, hey? We will send the recording through as soon as it's prepped.
As soon as it's ready, I will let you know.
Okay, that's good.
Sometimes teams take a little while to process it, but the moment I've got it, you'll have it.
It's usually within the 24 hours, hey, Marinus?
Yeah.
Okay.
So you'll have it in no time. And next week, once we've dealt with any revision questions or anything that you have about this, and remember what I said, every one of these entries has its own message queue, because the next topic is going to be message handling.
Okay.
Yes, we got quite far today. I hope it wasn't too quick. But any questions, please send them to me. Really. Okay.
All right,
Thank you so much.
And Marinus, thank you very much. And Neil as well. So thank you.
All you guys, don't fret. It's easy. I really promise you that. Just sounds complicated to begin with. Okay. All right.
Bye-bye.
Have a good day,
everybody. Take care.
Bye.
Thank you.
Okay,
Thank
bye-bye.
you.
Bye.
Bye.
Yes.
Are you stopping the recording, Marinus?
I am.
I think that went